This is a close-up of our single degree of freedom rig where we can show in more detail some of the individual elements within it. Here's the mass, which is able to move backwards and forwards freely. So the whole body here with various pieces attached to it constitutes the mass in this case. It's sitting on an air bearing, which you can hear the hissing as the air comes out of tiny holes in there and provides a cushion of air essentially to minimise the friction on which this mass sits and is able to move backwards and forwards there very freely with very little restoring force. We have a spring here, which is of course providing the restoring force. That's our spring in our single degree of freedom mass spring system. We have here the magnetostrictive displacement transducer, the blue rod with the ring that moves with the mass over it, and that provides us with a measurement of the displacement in voltage, which is provided to the oscilloscope via this cable separately. Here we have our copper bar, which in combination with these two electromagnets and the damper current control introduces some damping into the system. So we convert the system from being free vibrating single degree of freedom system, undamped I should say, to a damped single degree of freedom system. And as we increase the current, you can see the influence of the damping very clearly. There's very little vibration at all, but these are still all undamped, underdamped cases for this vibration. Here we have our frame speed controller, which we can adjust the frequency of the motor, which has a 3mm eccentricity and drives the entire black frame backwards and forwards, so it's simulating a base motion scenario. And if we have some damping here so we don't have a resonance situation, when I tune this frame speed to the resonant frequency, this is very close to resonance. This is our maximum amplitude vibration for this half amp lightly damped case. Here is our card that shows the parameters for this system. We have a free mass of 1.187 kilograms. We have a driving amplitude, as I've mentioned, of 3mm peak to peak, and we have a mass displacement scaling for the transducer of 15.08 millimeters per volt.